Hi guys, this is gonna be the first video of two on how to do a Gyrocam using this tiny component, the BNO055. It's gonna be, well, this project is for my motorcycle, and we're gonna be using this to create a Gyrocam, wireless Gyrocam that is gonna be communicating to a second unit, which is gonna be the driver. So this video is gonna be followed by another video on how to program this thing, and then followed by two videos on how to create the driver and how to program that as well. So let me show you what the major components are going to be. I also uploaded the Eagle project so you guys can download it and use the video to complete the project successfully. So let me show you what the major components are. So the first one is going to be this unit here. Is the BNO055, and the Eagle project is for this board here, not for those. So if you're gonna follow along, make sure you buy this one. There is a lead time of about 3 weeks, so it's gonna take a while to get this. Also, it's gonna require this little unit here. This one and this unit are the same. This one has longer range, but this one's cheaper, so they're not gonna be that far apart. This one, the communications on this one is, I think it's like 20 feet, but they're gonna be within 5 feet of each other. So the HM11 Bluetooth version 4, it's 375. This is where I get it from. You can get it from wherever you want. Also, they sell it here as well. It's a little more expensive, obviously, than on the other one, but not by much. So, buy it from wherever you feel like it. So this is just gonna be for communicating with the phone, for debugging as well for configuring the unit. And it also requires this wireless unit. This is gonna be for sending the wireless orientation of the unit to the driver. So it's gonna require two of this. Uh, you are also going to need this piece of software, the STM32Cube IDE. It's a free IDE software from ST, so you can go and download it, and I'll show you how to use this to program the ARM processor. And you are going to need this ST-Link version 2 programmer. You can use this one or you can use this one. Either way, it'll work. I'm going to be using this, so your choice. I have this one as well, but it requires a lot more pins, so I tend to go with this one for ease of use. And if you modify, you can also debug with it, but we're not gonna go into that. So let me show you the layout. This layout has been uploaded to the internet, and I'll show you guys the link. I'll also put the link in the description so you can download it and follow along. So it requires minimum components. We have a header for the BNO gyroscope here. We have a header for the ST-Link programmer. We have the placement for the mini NRF. We have the placement for the Bluetooth right here. And then we have a few LEDs and connectors, and that's about it. As far as components go, small components, we don't have that many. Here's the list. So it's 4 capacitors, actually 6 capacitors. So these are the bypass capacitors. The small one is for the processor, so it can get as close as possible. These ones are for the BNO and the 2 wireless units. We have a 1K resistor, 2 microfarad capacitors for the regulator, 1K, 10K resistors, and these are the sizes. So you can see this one's a 603, very small, medium size 805s, all of them. We have resistors for the LEDs, 4 of them. We also need 4 LEDs. This is just I don't remember where this one connects to, but we'll get to it. This is the regulator. It's an LDO 3.3 volts regulator, HM11. This is just the header for it's a 2 millimeter pitch for the battery, which is a 250 milliamp battery, NRF 24 wireless unit. The processor is the STM32G070KBT6 from ST. And then these are my LEDs, and these are just the headers. So it's an 8-pin header for the BNO, a 4-pin header for the ST link. So let's go to the schematic, see what we have. Here's the link where you can download it, and it'll be on the description as well. So by the way, if you don't know how to use how to program an ARM processor, we're gonna get to that on the second video. We're gonna do one from scratch, so you can follow along and you'll have a successful unit. Again, processor is an STM32G070KBT6. These are just about $1, I think. Let's see. So it's an STM G0, no, STM32 G0. What was the rest? 70KBT, 70KBT6, and it's 32. Did I not copy it right? Let's see if I can get the name from it. Can I copy it? No, I cannot copy it. STM32G070. So STM32G070. This one. $2. Okay, it's not $1, it's $2. Okay, so so that's the processor. The connections from pin number 1 all the way to 32. So we have 4 pins. The 3 pins. The first 3 pins are just for LEDs indicators. We might use them for connection activity, power up. We'll see. It's just for signaling. We have the 4 and 5, which is just power and ground. Reset pin for programming. At the bottom, 9 and 10 are for communicating with the Bluetooth module. We are going to be communicating with it through serial communication. So we have the transmission line that goes to the receiving line of the HM11. We have the receiving line on our processor that goes to the transmission line of the HM11. And then we have 5 pins at the bottom, 12 to 16, that are going to be for communicating via SPI to the mini NRF24. This one requires a lot of connections, obviously. SPI requires a minimum of 3, ideally 4. So the minimum is the clock, which will be 12, master out, slave in, which is 14, and then the chip select, which is 15. But we're doing communications both ways, so we'll require a lot more. Plus 16, that is for signaling the NRF if it's going to be transmitting or receiving. So we have the clock, master in, slave out, master out, slave in, chip select, and CE. Don't know what CE stands for, don't remember, doesn't matter, I know what it does. Pin number 24, which is for ST-Link programming. 25, which is for programming as well, and this is a require. It needs to be connected to power via ideally via a resistor. So we have it connected to 3.3 volts via 470 ohm resistor. And I think this is probably the biggest issue people have when they start with ARMs or ARM processors, because they can't get it to boot, and this is why, because you're not connecting your boot pin to power. So this is the biggest issue with beginners. We have 30, which is the gyro data is just an interrupt. that I was planning on using, but I'm not going to use it because we are just going to get the data whenever we feel like it, since we only want the current rotation of the unit, and we don't care when it changes, only when we want it, we'll go get it. We are connecting to the gyroscope BNO055 via I2C, and requires 2 pins, requires the SCL and SDA. Don't know what those stand for either, but those are the 2 connections we're going to be using, 32 and 31. And so if we start from the bottom right, we have the HM11, but require 2 connections minimum, and those are the 2 connections that go to the processor. It requires the key pin to be connected to power and via a 1K resistor, at least according to the documentation. We're also gonna connect pin, the indicator, the connection indicator pin, which is 15. So it has a 330 ohm resistor to a blue LED to ground, and this one is going to be blinking when it's not connected to any device, and it's going to be connected. It's going to be solid blue when it's connected to a device. In our case, it will be connected to the phone, and obviously it requires the ground and power minimum connections. The mini NRF, all the pins are going to be connected except number 8. We're not going to be using interrupts on this one either, because we'll get data when we get data, and we'll send data when we want to send data. We don't care anything about anything else. So the connections are from top to bottom: power 3.3 volts, ground, the C8 pin, chip select, the clock, master out, master in, and not connected. The this header here, this is for the programmer for the ST-Link version 2. We have our SW clock, I think that's what it's called, or boot pin, the DIO pin, ground and power, and then we have the BNO header, which is power 3.3 volts, ground, the connections for I2C with 3 and 4, SCL, SDA, and then pin number 5 is connected to power. I don't remember what this is, maybe COM3, I think, and I don't remember what this is either, but those 2 need to be connected to power. This one through a 10K resistor. The documentation specifies why. I don't remember why, I just have it connected. Obviously this is not a new schematic, I had it for a few months. And number 8 is not connected. This is the one for the interrupt. However, we're not going to be using it. It's just connected, but it's not really needed, and it's just a straight connection, so it doesn't matter if it's there or not. These are the additional 3 LEDs. These are the connections for the processor: red, yellow, and green, and they connect through 330 ohm resistors. It can be any value you want. Obviously, the lower the value, the brighter it will be, up to a certain level before it burns. The higher the value, the dimmer it will be until you can't see it, and they connect straight to ground. This is the LDO 3.3 volt regulator, and this is just the header for a JST 2.0 millimeter pitch connector. This is for a battery. The one I'm going to be using is a 250 milliamp battery, and it connects to this header. Even though it says 12 volts, it'll be at 3.3, but if you connect it to a higher voltage, that's why this is there. It doesn't have any safety diode, so if you connect it reversed, you might burn it, so be careful with it. Regulator and the 2 microfarad capacitors on each end, and these are just 0.1 microfarad bypass capacitors, one for the processor, one for the NRF, one for the HM11, and one for the BNO. So that's all I have. So 4, 1, 2, 3, 4. Let's see what else. I think that's it. So the board is pretty basic. The bottom part you can see is mostly a ground plane. I'm using it as well to route power without cutting the plane too much. It has route through here. So this side, and this side. And the top is mainly signal with ground as well, wherever I can put it. And it has vias for through-hole plating. If you don't have the capability of doing through-hole plating, then you can add a large via here, maybe one here, and that's about it. It should work because everything else has a path to ground. Obviously the idea here is to have the shortest path to ground, so there's no interference anywhere. But you can get away with it. This is not a critical board, so you can just put one here, and you'll be good to go. I also have this here. Even though this is supposed to be connected to here, this is not required. I have it like this because I do want to wire a switch that is going to be mounted on the side of the enclosure of this unit. So it gives me the option of wiring through here power so I can have an external switch. Or if I don't have the switch, I can just solder this together and it will be good to go. This is just indicators to tell me which side is power, which side is not. So because there's no protection against reverse connection, I want to make sure that it is connected there. Let's see, obviously minimum connections. Let's go look at the values. So 1K connection to the key pin, 330 to blue LED, and then this is ground to power 1 microfarad capacitor. Here is your regulator, two 2 microfarad capacitors for the regulator. These are your 330 resistors. These are your indicator lights, green, yellow, and red. Processor, 1 microfarad capacitor for the NRF, 1 microfarad capacitor for the this is not for that one, this is for the programmer. It's right here. Let me show it. Paths right here. So it's ground, I think it's power and ground. So yeah, ground power. And then we have a 10K, which is for the BNO. This is a 470 ohm resistor, so resistor. One is for this processor for the boot, and this is for the BNO. Don't remember for what, but it is required. And now that I'm looking at it, this one doesn't have any 0.1 microfarad filtering capacitor. So there's one for this, which is the one right here, one for this, which is the one right here, and one for the NRF for here, one for the HM, which is here, and that's it. It's pretty simple. That's the top. Let me remove the wrong one. This right here. Okay, so that's it. So this is going to be followed by a video on showing you how to program the ARM processor. And like I said, don't worry if you don't know how to do that. We are going to go from scratch all the way to getting it to run. So, but you will need this STM32Cube IDE. It's free. Download it from ST, and you will need this sucker. And the second video is going to be followed by 2 more videos on how to do the other unit, and it's going to have the same format where I'm going to give you the layout, and then we'll just do the programming for the driver itself. So that's all I have. The download link will be on the description, this right here. So until next video, hopefully by the end of the week I'll have the next video. I still have to print my board and do all the chemical process it needs to have, all the drilling, mount the components, and then once we're ready to start writing code, then I'll upload the next video. All right, enjoy.